Hello friends, welcome back to the lecture series on network security. To recall, in the previous lecture we had studied about the various algorithms related to cryptography like public key crypto system as well as classical crypto system. In classical crypto system, also called the symmetric key crypto system, we have both the keys for the sender and the receiver which are same. And for public key crypto system, which is also called asymmetric key crypto system, the keys are different. We also touched upon some of the classical key cryptographic algorithms like Playfair cipher and Caesar cipher. Today we are going to study some more algorithms of classical crypto system. So let us start with substitution techniques for classical key crypto system as well as transposition technique for classical key crypto system. Now this substitution technique for classical key crypto system, mainly in this case what happens, we are substituting one word for the other. Like if we have a plaintext X, in place of plaintext X, we can transmit plaintext Z based on some algorithm. So the algorithms which we are going to study under substitution techniques are Hill cipher and polyalphabetic cipher. And then we will move on to the transposition technique of the classical key crypto system, and the algorithm, the name of the algorithm is rail fence technique. Here, instead of substituting one letter for the other, the letters that are to be transmitted are permuted based on some algorithm. So let us start with the Hill cipher under substitution key crypto system. To look into this, here the encryption algorithm takes m plaintext letters at a time. It takes m plaintext letters at a time and substitutes them for one cipher for each. Now since we are taking m letters at a time, so we have to form m linear equations. So m linear equations are formed in which each character is assigned a numerical value. Now let us take the example of the English alphabet. So there are 26 letters in English alphabet. We can assign the values from 0 through 25. That means the letter A, when it comes, will be assigned the value 0. The letter B will be assigned the value 1, the letter C will be assigned the value 2, and so on up to Z, which will be assigned the value 25. Now let us consider one example where m equal to 3. That means here we will be dealing with 3 letters at a time from the plaintext. So correspondingly there should be 3 ciphertext for the 3 plaintext letters. Let us see how we form the equations. Let's say for the first letter, like plaintext, if we consider the plaintext letter to be P and the ciphertext letter to be C, then for the first ciphertext C1, we can write K11 P1 plus K12 P2 plus K13 P3 total mod 26. Why mod 26? Because there are 26 letters of English alphabet. Now here K11, K12 and K13, they form the first row of the key matrix that will be given to you. And this P1, P2, P3 are the 3 consecutive letters to be to be formed into ciphertext. These are actually the plaintext letters. Let's go to next the ciphertext 2 or C2. It can be written as K21 P1 plus K22 P2 plus K23 P3 multiplied by, that is, mod 26. And the last one C3 can similarly be written as K31 P1 plus K32 P2 plus K33 P3 mod of 26. So in general we can write the ciphertext C to be equal to K multiplied by P mod of 26. So let's look at it with an example. Now in this example I have to transmit the plaintext letters pay more money. That means PAY, MORE, MONEY. So these are the 3 words that need to be transmitted over the channel. And you have been given the key matrix K to be a 3 by 3 square matrix. So by looking at the size of k, we can understand how many letters we have to take at a time. So based on that, how many linear equations can be formed. Since here k is a 3 by 3 matrix, so definitely we have to form 3 linear equations, and that is why we are taking 3 letters at a time. So let's take 3 letters from here. So what are the 3 letters? PAY, that means pay. So instead of transmitting PAY, we have to transmit the ciphertext corresponding to letters P, A and Y. Now as I said, this PAY should be a column matrix, single column matrix, and you have to assign the values to P, A and Y. And as I said, the values that are assigned to these letters are starting from A equal to 0 through Z equal to 25. So in that case, P comes out to be 15, A comes out to be 0 and Y comes out to be 24. So we get a column matrix for the 3 letters PAY. Next, you multiply that K. Here we have to do matrix multiplication. So multiply the K matrix with this column matrix of the plain text letters, that is PAY, and take mod 26. So after calculation, in the second step we will be getting 375, 819 and 486 mod 26. So finally we will be arriving at 11, 13 and 18. Now again this 11, 13 and 18 should be transformed back to the letters. So accordingly 11 stands for L, 13 stands for N and 18 will stand for S. So we have created the ciphertext for the plain text letters P, A and Y. So instead of sending P, A, Y, we will be sending L, N and S. So I hope this is clear to you. Now let us go to the decryption algorithm. How the receiver will decrypt it back to PAY. Now for decryption algorithm, you have to take the inverse of the key matrix that has been given to you. So I hope all of you are aware of how to find out the inverse of a matrix. So following that procedure, you can find out that inverse of the matrix K that has been given is as follows. So this will also be a 3 by 3 matrix. Now in order to find out P, that means in order to get back the plain text letters, you have to simply multiply the K inverse with C and take the mod of 26. So that way you can encrypt it as well as decrypt it by using the substitution technique, which is called the Hill cipher. Now let's go to the next topic of substitution technique, which is called the polyalphabetic cipher. So long we had been dealing with monoalphabetic cipher, meaning each letter will be assigned a ciphertext. That means letter E, let's say letter E is assigned the value of letter J. So all the time in the text, wherever you are getting the letter E, you will be replacing it with the letter J. So this is called the monoalphabetic cipher. But for monoalphabetic cipher, as I explained in the previous class, based on the frequency of occurrence of English alphabets, the hackers can break the code and they can get hold of the plain text from the ciphertext. So we are moving over to an improved version of the substitution technique where we are using polyalphabetic cipher. What happens in polyalphabetic cipher? We will have to use different monoalphabetic substitution rules as we proceed through the plain text. That means the letter E may be assigned at one point of time in the total text. It may be assigned the letter J at one point of time, and at other point of time it may be assigned the letter M based on some keyword. Let's see how we can do it. Here I have given you one example. Here the key is deceptive. Let's say DECEPTIVE. And the plain text that we are giving is, we are discovered, save yourself. We are discovered, save yourself. So what we should do now? Write down the plain text as it is given. So, we are discovered, save yourself, right? Now, you immediately above that, that means in the first row, you write down the key. So, the keyword is deceptive. So, you go on repeating the word deceptive till you reach the end of the plain text. So, here we are, how many times we are repeating? We are writing deceptive. That means we are writing for each letter of the key should coincide with each letter of the plain text one by one. So, deceptive, here we end one form of deceptive, again we start writing deceptive, you are ending over here and again. So, here 3 times you have to write deceptive, since the plain text is so long that it requires 3 times the keyword to be written. Now, what you should do? Based on the key and the plain text, you will get a ciphertext. A very interesting thing over here, let's look at the second letter from the left, E. See, here E has been assigned the ciphertext of I. So, here I have written the ciphertext in capital case and plain text in small case. So, E has been assigned the letter I in the first case, and you see 1, 2, 3, 4, 5. The fifth letter is also E in the plain text. There, instead of I have given T. So, this is called polyalphabetic substitution. Like the same letter in different point of the text will have different ciphertext. So, it becomes very difficult for the hacker to hack the code. Now, let us see how we are doing it. Basically, we will be doing it with the help of a table which is called the Regina Table. This table is Regina Table, and how to form this table? You see, there are number of rows and number of columns. First, in order to form this table, you write down the plain text letters starting from A going up to Z. That means there should be 26 columns. Each column consisting of the letters A through Z. Similarly, at the left hand side you see I have written the same letters in italic forms, and that is represented by the key. Now, you fill up the entire that means 26 by 26. You fill it up with the capital case letters. So, the first row will start from A and will end with Z. The second row you just make a right shifting. So, the second row will start with B and it will end with A. The third row will start with C and it will end with B, and so on till you reach the last row, which will start with Z and it will end with Y. So, you have finished a 26 by 26 matrix. Now, how to do the ciphertexting? Let us go back again. You see, for let us say we have to make the ciphertext for the letter W, which falls in the plain text. Now, you see, actually the ciphertext is formed by a combination of the key letter and the plain text letter. So, the key letter is D over here and the plain text is W over here. So, since the key is D, you draw a horizontal line along this row. Draw a horizontal line along the row containing the letter of the key. So, in this case it is D, and you draw a line which is vertical containing the letter W, which falls into the plain text. So, at the intersection of the two lines, you will find there a letter which will be your ciphertext letter for that particular plain text letter. In this case, it will be Z. So, in this way, you can form. Let us look at the second one. It is key is E as well as the plain text letter is also key. We are looking into the second letter from left. So, going back, you can find that if key is E, so you are drawing a horizontal line along this row, that means along the fifth row, and as well as my plain text letter is also E. So, you draw another vertical line along this column. So, the intersection of the two lines will give you the ciphertext for that particular plain text. In this case, it is I. So, here E has been replaced by the ciphertext letter I. So, in this fashion, you can carry on with your ciphertexting. So, this is called the polyalphabetic cipher, and the table which we are using is called the Regina Table. Next, let us go to the transposition technique. Unlike the substitution technique where we are substituting each letter with a cipher letter, here all the letters that form the plain text are reshuffled according to some keyword, and this is called the permutation technique. So, first comes the rail fence technique. What happens in rail fence technique? The plain text is written down as a sequence of diagonals. The plain text should be written down as a sequence of diagonals, and they should be read off as a sequence of rows. How? Here, let us say plain text is meet me after the meeting. Plain text is meet me after the meeting, and you have been said that there should be 2 rows. So, here the keyword is 2. So, 2 rows you should use to write down the plain text. So, how are we writing down? As I said, they should be written down in diagonals. That means you create 2 rows and start writing in diagonal form. So, the first letter will form the first letter of the first row, and the second letter you write in a diagonal form. So, M E, again E T. So, this comes meet, me, A F T E R, after T H E, the, M double E T I N G. I am repeating again. You write it down in diagonal form. Here the keyword is, key letter is 2. So, there should be 2 rows. Start writing from the first row. So, M E E T, M E A F T E R, T H E M E E T I N G. So, that completes my writing of the plain text in forms of diagonals in 2 rows. Now, how to form the ciphertext? Again, we are mentioning once more, the ciphertext should be written in capital case letters and plain text should be written in small case letters, just to differentiate between the two. Now, once you have written it, how to read it out? You read it out in rows, in sequence of rows. So, you first read out the first row, then read out the second row. So, your ciphertext will now become M E M A T R H M E I G. Then you have completed the first row, come back to the second row, E T E F E T E E T N. So, when this goes through your channel, nobody will be able to identify what message you have sent. Now, this goes for the encryption part. Now, how to decrypt the message from the receiving end? Again, since the key letter here is 2, that means the receiver should also know that there are 2 rows. What you have to do? You have to divide the ciphertext letters into number of rows. Here, the letters are 21 in number. So, what you need to do? You add 1 to it. That means you get 22 divided by the number of rows. So, if it is odd, you add 1. So, since 21 is odd, you are adding 1 because you have to divide by 2, which is even. So, if you divide by 2, you get 11. So, the first row will consist of 11 letters and the second row will consist of the remaining letters. You start counting by taking a letter then from each block. So, what will happen? You see, you are subdividing it into 2 blocks since there are 2 rows. So, the first block will consist of letters from M to G, 11 letters, and the rest 10 letters will be into the next section. Now, how to read it out? you read each letter one by one letter from the two blocks. That means first letter from first block, second letter from second block. Again the third letter from first block, fourth letter from the second block, and so on. So you can very well see that this becomes M E E T M E, that is meet me, then A F T E R, and so on. So you will be able to decipher the message at the receiving end after you do the decryption algorithm. So this is called the simplest of all rail-fence technique. Under which category? It falls under the category of transposition technique. Now here, this one I am showing you with the same plain text letter, but here I am taking 3 rows. So the keyword will be 3. So here's again the same plain text I am taking, meet me after the meeting. So it should be written in diagonals in 3 rows. So you start writing like this, M E E. So 3 rows completed. Again start from the first row, that is second letter. So T M E A F T, and so on. You have completed writing the letters of the plain text in diagonal form in 3 rows. Now you start reading in sequence of rows. So what will be your ciphertext now? It will be M T A E H E I, then E M F R E E N E E T T M T G. So this will be your ciphertext. Now how to decrypt the algorithm? You see here again we know that it has 21 letters. Now you see you can easily divide 21 by 3, it will come in a block of 7. So 7 means you have then 3 blocks. To 3 blocks you start taking 1 letter from each block. So my decrypted text will be the first letter from the first block, that is M, then the first letter from the second block, that is E, and the first letter from the third block, that is again E. So if you start doing it, you will be getting back meet me after the meeting. So this is about the rail fence technique. Now we will move on to a more advanced form of rail fence technique. As we can see, we are trying to make the schemes more and more complex so that it becomes very difficult for the hacker to hack the code or break the code. Here what we are doing, we are writing the message in a rectangle row by row. We should be writing the message in a rectangle row by row, and then you should be reading the message off column by column, but permute the order of the column based on some keyword. So first write down the plain text letter in a rectangular form by writing it in row by row format. Then you read it out column by column based on some of the permutation scheme which is given as the keyword. Here again we are using the same plain text, meet me after the meeting, and the key given over here is 4 3 1 2 5 6 7. That means you have to form a rectangle consisting of 7 number of columns. So since there are 21 letters, so you can very well understand that there will be 3 rows. So you start writing it like this in the rectangular format row by row. So MEET MEA, this finishes the first row. Then we move on to the second row, FTERTHE, then comes the third row, MEETING. That completes my formation of the rectangle. Now what we need to do? We have to read them out column wise. But how column wise? Based on the keyword that is given to you. That means the first column that should be read should be under the figure 1. That means you are reading it out like this, EEE. So EEE comes first, then comes the second column, that is TRT. Then comes the third one. You have to find out which is the third row. So here comes the third row, third column. So it becomes ETE. Then comes the fourth one, MFM. Then comes the fifth one, which is MTI. Then comes the sixth one, which is EHN. And lastly, we get the column 7, which is AEG. So you have now your ciphertext, which is very much different from your plain text, and it cannot be understood by anybody who does not have the key. Now, this type of transposition technique can made be more secure by performing more than one stage of transformation. How? And then recrypting the above message with the same key. How we are doing it? Let's say again the plain text will be meet me after the meeting. So after the first stage of ciphertext, we have already received this as shown in the previous slide. Now you are using the same key once again, and then again recrypting it. That means re-encrypting this. So this one now forms my plain text for the second stage of ciphertexting. So again you form the same rectangle row by row and read them out column by column based on the key letters that is given to you. And ultimately, after the second stage of ciphertext, we arrive at this ciphertext, which is now very complex for anybody to understand. Now, today we have studied some of the classical key cryptosystem techniques which falls under the category of substitution technique. Number 1, we have studied Hill cipher, and number 2, we have studied polyalphabetic cipher, which uses Regina Table. And we have also touched upon some techniques of transposition ciphertexting, which also falls under the category of classical cryptosystem, and we have looked how the rail fence technique can be made more and more secure by creating more and more complex algorithm. Actually, the idea is we are learning these algorithms, but with your cleverness and with your mathematical skill, you can devise your own algorithm based on these basic algorithms that have already been devised. In the next few lectures, we will be studying more about the classical key cryptosystem. Till then, goodbye and thank you.